Okay, this is the formal geometry for at Damani Ranch High School lesson for chapter 5.6, which is based on this idea called the Hinge Theorem. Okay, so first of all, let's go ahead and define what the Hinge Theorem is. The Hinge Theorem tells us that if two sides of a triangle are congruent to two sides of another triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. Then the third side of the first triangle is longer than the third side of the second triangle. Hold on, let's just go ahead and draw this out. I think I read it all crazy. I'm losing my voice over here. Okay, so I'm going to draw two triangles, and I'm going to intentionally make them look like they're the same, just so that we have to rely on the information and not what the figure looks like. Okay, so I'm going to call this ABC, and I'm going to call this one DEF. Okay, so if I have two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, I'm going to call that smaller, then we can figure out a thing or two about this third side. Okay, so what the Hinge theorem tells us is that if we have this situation, then the third side of the first triangle with a larger angle is longer than the third side of the second triangle. This angle, side length EF would be shorter. Okay, I don't know anything about what the lengths actually are, but I do know that that if angle A is less than angle D, and if DF is congruent to AC and AB is congruent to DE, then I do know that BC must be larger than EF. So the converse of this is also true, that if I have two triangles and they are the same kind of setup where I have two sides of a triangle are congruent to one another, and the third side of one is longer, why do I keep writing it like that, than the third side of the other, then I can also know that there's a relationship between the angles of each triangle. So if I have, again, ABC and then DEF, based on the converse of the Hinge theorem, I can assume that angle A is larger than angle D. Again, I don't know anything about the measures of the angle, but I do know that angle A has to be bigger, okay? This is because these side lengths are the same, okay? So if you think about this, the reason it's called the Hinge theorem is you think about a door. Okay, so think about the door and you open the door wide. Well, if you were going to draw a line across, like to make a triangle out of the angle that's being formed, then that would be larger than if I had the door only opened a little bit. So if the angle is bigger, the third side is bigger. If the angle is smaller, the third side is smaller. Okay, it kind of makes sense. So we're going to set this up in some examples. So I'm going to go ahead and do the first couple here, working it out. We'll go over it all, and then I'm going to have you guys do numbers 3 and 4 on your own, but then I'll pop up the answers, and number 5 we'll kind of talk about together, quote unquote. I'm really sitting alone in a room talking to myself, but it's okay. Okay. All right, so I have a situation here, okay? I have two triangles. Hopefully you see these two triangles. So let's go ahead and understand the diagram before we dive into the equation, or setting up an equation. So I can see that they told me that those two side lengths are congruent, okay? I have some lengths of these sides over here, and I have some expressions or values for some angles, okay? So what are they asking me to find? They're asking me to find the range of values for the variable, okay? The range of values for the variable. Well, I don't really know. I can't set 2x minus 5 equal to 59. That's very tempting, but I can't do that because these are not the same third sides. These are not congruent triangles, okay? I do know that that side is congruent to itself because of reflexive property. So I can see now that I have a Hinge theorem situation. I know that I can assume that this angle is less than 59 degrees. The reason I can assume that is because this side length is less than that second side length. 15 is less than 18. So based on that, I can assume that 2x minus 5 is less than 59. That's all I can assume, okay? So, I'm not doing here good. Hopefully my voice isn't too crazy. So if I work this through, I know that x is less than 32. Okay, great. So that's my range. That's my range of values. That's all I can tell. Okay. So let's go ahead and look at example 2. All right, so this one is looking at, this one's a tiny bit different of a setup, okay? I can see that I have 2 triangles. Those 2 triangles each have 2 side lengths congruent, this one that I labeled in purple and this other one that was notated on the figure, okay? So I have 2 side lengths congruent, and then I have an expression for my third side and then a value for my third side on the other triangle. I am also given an angle, and this angle is opposite the third side in question, okay? So based on the Hinge theorem, because 71 degrees is bigger than 64 degrees, I know that 20 has to be greater than this expression, okay? Let me say that a different way. Because this angle is smaller than the corresponding angle in the second triangle, I know that 2x minus 3 must be less than 20. And that is an inequality that I can solve if I, and that's all I know. I don't know anything about what the actual measure of the angle is. I don't know, or length of the side is. I don't know anything about that. All I know is the possibility that this side length here must be smaller than this one based on the Hinge theorem. Okay, so I can go ahead and solve this for x, and I would get that x is less than 23 over 2. Okay. So let's go ahead and look at examples 3 and 4. And I'm just going to pause it here and let you guys go ahead and set this up. They're very similar to 1 and 2. Pause the video, work these on your own, come back and check your answers. Okay, so for example 3, you should have seen that angle, the expression given for one angle, which is 6x minus 1, that has to be greater than 71 degrees. So if you solve that through, you would find out that the variable must be greater than 12. In example number 4, you can see that because this this side is opposite an angle that is larger, it must be larger than this side. So 4x minus 10 must be greater than 40. If we solve that through and reduce our fractions, we would get 25 over 2. Okay, so let's go ahead and look at number 5 together, okay? So this one looks almost exactly the same as problem number 4, okay? We have the same angle measures in those particular angles, and then the same expression. Is it the exact same expression? No, slightly different expressions, but the same kind of information, okay? So based on the Hinge theorem, I know one thing. I know that 4x minus 10 must be greater than 37, okay? But I have another theorem that I have to come into play here because they gave me more information on this triangle. I know this side length and this side length, okay? I know that the sum of those two side lengths must be greater than, in order to form a triangle, the sum of these two side lengths highlighted in pink must be greater than the third. Okay, so I'm going to write that out. Okay, so I know that 20 plus 24 also must be greater than 4x minus 10. Okay, so I know that I have two inequalities here. So I'm going to go ahead and put these things both together. Okay, I'm going to put the expression in question, I'm going to put it in the middle. I'm going to say 4x minus 10. Okay, well, I know that that has to be greater than 37, but I know that this sum of 20 plus 24 must be greater than it. So this expression must be less than 44. Okay, so that gives me a compound inequality that I can solve through. Okay, so I would add 10. I'm not sure that many of our Damani Ranch students have seen a lot of compound inequalities in their algebra classes during COVID years. Hello, I can add, but I'll go ahead and solve this out. So I'm going to get 47 over 4 is less than x is less than, that reduces to 27 over 2. And you can punch this in a calculator if you want. This is 11.75 is less than x is less than 13.5. Okay, so let's just recap how I set up my two inequalities, okay? My first inequality is using the Hinge theorem. That's what we've been doing throughout this section. Hopefully that makes sense. My second inequality, this one right here, is using what we covered in, let's see, what section was it? 5.5, which is the triangle inequality. That tells me that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay? So the sum of the lengths of two sides of a triangle must be greater than the third side. And that is how I got my second inequality. I went ahead and put them together to solve in one equation, and that gave me my range of possibilities for the variable. Okay, this concludes this is 5.6, now I remember, 5.6, and this actually concludes chapter 5. So at this point, you should be ready for any quizzes that might be on the schedule and be ready to start studying for your unit test.